Hi, this is Sanil Rege from PsychScene.com. Today I'm going to take you through a systematic review and a meta-analysis um, through an article from the British Journal of Psychiatry. As you can see, the pharmacotherapy for post-traumatic stress disorder. Before we start off, I'm just going to touch very quickly on the basics of a systematic review and meta-analysis. Um, a systematic review and a meta-analysis basically consists of a compilation of usually randomized control trials that are pooled together to then give a combined review, and the graphical representation of that review is a meta-analysis. So, as we know, any researcher looks to minimize four types of biases um, in any study. These biases include selection bias, confounding bias, attrition bias, and measurement bias. Many of you might have already recognized that because systematic review consists of a compilation of randomized control trials, some of these biases may not apply. So the main biases that I will be looking out for in this meta-analysis are selection bias. A specific term for that in a systematic review is called a publication bias. And there are several variations of that, such as language bias, indexation bias, etc., etc. The second aspect I'm going to look at is whether the researchers have minimized information bias or measurement bias, and this is done by ensuring that there are independent reviewers for the articles that they're weighting. What I mean by that is all these randomized control trials that will be compiled will need to be given a particular weight based on their quality. And this needs to be done independently, otherwise it could lead to spurious results. And finally, once these two biases are minimized, you then write your systematic review and construct a meta-analysis, and the measures of effect can be depending on how the data has been arranged, whether it's categorical or continuous. You would have either odds ratio, relative risk, standardized mean difference, etc. Look at the p-values, the confidence intervals. You graphically analyze your meta-analysis, which we'll be doing later. And then, of course, finally, the term that you've come across before is heterogeneity. Look for heterogeneity in this systematic review. The concept of heterogeneity essentially means that we want to compare apples versus apples, not apples versus pears. If there is too much heterogeneity in the meta-analysis, the results may not really be useful. So that's essentially what we're going to go through in this paper. So this paper is a 2015 article in the British Journal of Psychiatry. It's called Pharmacotherapy for Post-Traumatic Stress Disorder, Systematic Review and Meta-Analysis. So let's scroll down. We are not going through the abstract because we're going to appraise the paper in more detail. So the first thing I do when I look at the meta-analysis is, of course, look at the methodology. So let's see what the researchers have done. They've said all double-blind, randomized, placebo-controlled, and comparative trials of the pharmacological treatment of PTSD completed from October 2005 were considered in our primary and additional searches covering 13 separate databases. So they've tried to obtain as many papers, as many published and unpublished data there is to compiling this systematic review. And that's really important because in order to minimize publication bias, we need to compile as many, we need to find as much published and unpublished data to compile in that review. What you can see here, published and unpublished abstracts and reports were also sought out in any language. This is, of course, to minimize the language bias. They then talk about the exclusion criteria, pharmacotherapy trials in which there were ongoing or newly initiated trauma-focused psychotherapy, or where the experimental medication served as an augmentation agent to ongoing pharmacotherapy were excluded. They then talk about open-label trials were not considered, clearly because open-label trials will have a lower quality than the double-blind trials. And they've talked about the preferred reporting items for systematic reviews and meta-analysis, which is the PRISMA checklist. This supersedes the quorum, which used to be the previous checklist for meta-analysis. Many of you who've done the psych evidence course will be aware of this. So once they've talked about the method in a bit more detail, they've talked about participants, interventions, outcome measures. Now I want to look at the search strategy in a bit more detail. So as you can see here, it says we conducted a primary bibliographic database search of Medline, Medline in Process, Embase, PsycInfo, Astia, Sanil, and the Ovid interface. So if you have a think of it, they've gone through quite a lot of effort through a number of databases to identify publications. This is important because if they only went through one or two, there is a high possibility that they would miss articles and therefore lead to a publication bias. In order to avoid language bias, they separately searched Japanese, Chinese, and WHO regional databases, and so Spanish, Russian, Portuguese languages. So they've gone through search as well to minimize language biases. What they've then done is they've also looked at additional searches for published and unpublished studies in the National Center for PTSD Pilots database, the Cochrane Library, the Controlled Trials Register, Web of Knowledge, etc. And then they've also gone through a reference list of all selected studies and reviews. They've contacted an expert group, and they've contacted authors of identified studies to request data if outcome information was missing. So they've gone through quite a thorough process. Essentially, the question that you ask yourself is, have they done enough to minimize publication bias? And could you do better? There's no right and wrong answer here. It's very subjective. They then talk about study selection. They talk about data extraction and risk of bias assessment. And what I want to see here is, have they now employed independent reviewers? And clearly you can see all data from newly identified studies were double extracted by 2 independent reviewers into a standardized table, and any discrepancies were discussed with a 3rd reviewer. This is because these studies are going to be weighted, and any study that has a higher weight will have a greater impact on the overall meta-analysis results. And that's why that's important, because have a think about it. If you were a researcher with a vested interest, then you could potentially choose a lower quality studies that has shown the result that you wanted and give it a higher weighting and essentially change the entire result of the meta-analysis. The risk of bias, again, 2 reviewers using the domain-based evaluation method independently assess risk of bias in individual studies. And that method consisted of the following domains. These domains, if you have a read of them, the random sequence generation, allocation, concealment, masking of participants and personnel, masking of outcome assessment, incomplete outcome data, selective reporting, other sources of bias. These are essentially the biases that we aim to reduce when we're appraising a randomized controlled trial. And why do we do this here? Because the articles that will be included, the authors have mentioned, they're using double-blind randomized controlled trials. They then talk about statistical analysis, and in this section usually they'll talk about the software, the confidence intervals at 95%. They've talked about categorical outcome measures where they use relative risk, and clearly for continuous data they use standardized mean difference. They've talked about heterogeneity and using the I-square statistic. You can also use the chi-square, and we'll see that later. So I've gone through this in quite a quick manner, and the reason I did this is because, of course, in the RANZAP and the MRC Psych exam, and of course in clinical practice, most papers have to be evaluated in 5 to 10 minutes maximum. It's really about how you apply this to clinical practice. So we're doing real life training. So now, once that's done, I ask myself, is the methodology good enough? Because the meta-analysis is based on the GIGO principle, garbage in, garbage out. So if the methodology is really poor and the quality of the studies are really poor, then what comes out as the result will also be poor. So in my opinion, they've done a good job, and I can now go to the results. And the results, as you can see here, are represented in a graphical format. So let's try to appraise this. So this is the graphical representation of the systematic review. On the left-hand side are all the studies that have been compiled in this systematic review. And sometimes you may see subgroups as well. Here there aren't subgroups. These are all the studies. And what are they looking at? This is the meta-analysis of SSRIs versus placebo. And you can see the measure of effect, standardized mean difference. So when you look at a meta-analysis, you look at the left-hand side, you see the groups and the subgroups. Okay, all these numbers, for the purposes of real life and in the exam as well, you can't go through these individually. The researchers have done that for you on the right-hand side by putting up a graph for you. So what do you look at when you look at the graph? The first thing on top, you can see here, look at the measure of effect. It's a standardized mean difference, and they've talked about 95% confidence intervals. Now, since it's a standardized mean difference, I know that the line of no effect will be 0. So if you want to check that, this line is the line of no effect, and you can see that the that value of no effect is 0. Now, these are individual studies. This little box is the effect size. Usually larger the box, larger the sample size. So from a quick eyeball, you can see that this study seems to have the largest box comparatively. And that's because if you look at the sample size, it's amongst the largest of all of them, 375 and 188 compared to any of the others. And at the same time, we will then interpret on which side it lies. The horizontal lines are confidence intervals. And what you want to see is, do the confidence intervals cross the line of no effect? Because if they do, then this study is not statistically significant, clearly because the confidence interval crosses the line of no effect. Okay, so very quickly again, you look at the measure of effect, standardized mean difference, the line of no effect, 0. I then ask myself, what's on the left, what's on the right? And as you can see here, I'll hover this out. On the left, it says favors experimental. On the right, it says favors control. So I know favors experimental means that it favors SSRI. Favors control means it favors placebo. So individual studies, as you can see, the first one is statistically significant. Second one, no. Third, yes. Fourth, no. Fifth is just barely touching it. If I do want to confirm it, I look on the left. It is actually statistically significant, as it does not cross the line of no effect because it's minus and minus. If it crossed the line of no effect, that would be plus. So similarly, I can do it for all individual studies. The key here is this diagram tells me everything I need to know. Now, suppose this diagram wasn't there, then I could go to the left-hand side and I can see standardized mean difference shows that there is a difference in the symptoms for SSRIs of 0.3 minus 0.34, and that is statistically significant because it does not cross the line of no effect, which is 0, and that's minus and minus. Whilst here you can see in the second one, it's minus 0.01, so there is a tiny difference, but clearly it's not statistically significant because it moves from minus to plus. Now, in a meta-analysis, one's not really bothered about individual studies. One's really concerned about this diamond here, which is the pooled effect size. Because the real advantage of a meta-analysis is that you can compile all these studies. You can compile all these studies to give you a pooled effect size. So by compiling all these studies, you increase the sample size, you increase the power, therefore you increase the likelihood of detecting a true difference when one truly exists. So you get the true result, the likely to result in the real population. So you can see here the pooled effect size clearly lies to the left. It favors experimental, i.e. favors SSRIs, and lies somewhere between 0 to minus 0.5. And that's the measure of effect. You can see here it's minus 0.23, and it is clearly statistically significant. So this is a very brief interpretation of a graph. And what I asked myself after that is, were the studies included fairly homogeneous, or was there significant heterogeneity present? Now, how do I find that out? It's a commonly asked question in the exam. I look at the left bottom side, and heterogeneity is almost always present here. Now, what's important here is all these numbers, don't worry too much about how they're calculated. The p-value tells me whether there's statistical significance or not. And we know most of the times p-value is set at less than 0.05, which basically means that there is a 5 in 100 probability, or 1 in 20 probability. The result you got is due to chance. Here you can see that there is a 2 in 1,000 probability that this result is due to chance, which means that there is highly likely a statistically significant heterogeneity, because this test that they've done, p-value, is to test for heterogeneity. If the p-value is statistically significant, it means that there is statistical significant heterogeneity. A really quick way to see if there is heterogeneity is to ask yourself, can I draw a line crossing the confidence intervals of all the studies? You can see that the line of effect does not do that. But even if you try to draw another line, you wouldn't be able to draw a line that crosses the confidence intervals of all the studies. That tells me that there is heterogeneity here. The third way is look at the I-square. The I-square tells us nothing but the variation in this plot that is due to variation in the individual studies. Lower the I-square, lower the heterogeneity. So here you can see there's moderate heterogeneity. It's 53%. So this is a quick graphical representation of the meta-analysis. Now, in the interpretation, we've seen that clearly the SSRIs come up trumps over placebo. Now, I want to see what is the efficacy and tolerability of individual agents versus placebo. So what I do here is I go to the pop-up again, and this one's not in graphical format. So whenever you see a table like this, candidates can get quite daunted with lots of numbers, but take a deep breath. There's nothing to worry about. The most important things are often trying to get a big picture understanding. So what I do is usually look around the box. Okay, as you can see here, you'll find most important things around. So first thing, efficacy and tolerability of individual agents versus placebo. I look around, there's nothing here. And down here, they've given abbreviations. They've talked about what the I-square statistic is. And most important here for me is the p-value less than 0.05, and that's the asterisk. So what I'm going to do is I'm going to try to search for an asterisk here. Let's look at paroxetine, PTSD symptoms clinician rated. You can see there's an asterisk here, which means paroxetine showed statistically significant difference in PTSD symptoms clinician rated compared to placebo. Here, self-reported, again statistically significant. We won't look at leaving study early. Sertraline, no asterisk, not statistically significant. No asterisk, not statistically significant. And really, even if there wasn't an asterisk, you could see just from the 95% confidence interval, it does not cross the line of no effect, therefore it is statistically significant. You can see it's minus, minus. So it goes minus here, minus, minus. That's statistically significant. Here, minus 0.13, but it goes from minus 0.27 to plus. So that's not statistically significant. So you can do this for the rest as well. So overall, this is statistically significant. Paroxetine, fluoxetine, yes, also. Go down, this one, no. Venlafaxine, yes. Olanzapine, no. Topiramate, no. So what we've got here is we've got paroxetine, fluoxetine, and venlafaxine. So those are three medications that have shown benefit. Now let's see what the results, what the authors have put down as a result. So let's scroll down, and in the discussion section, the first statement says, this systematic review found statistically significant evidence on meta-analysis for 3 pharmacological agents versus placebo in the treatment of PTSD, fluoxetine, paroxetine, and venlafaxine. So it's consistent with what we've just talked about. Now, if you want further practice, you can go to the trauma type sub-analysis of individual agents versus placebo. You can do the same thing here again. Go through the individual medications. Ask yourself, is there statistical significance? So I would go around, look down here again, asterisk, p less than 0.05. Again, look here, sertraline, no, yes, no, no, no. MAOIs, no. Venlafaxine, yes. So, and you can do the same for the rest. Okay. So this is in summary a discussion of meta-analysis. So I hope you found it useful. Um, uh, if you do have any difficulties in the basics, then you can always visit visit the Psych Scene website and visit the online course, the Psych Evidence course, um, which has everything explained in a lot more detail. And once you log in, you've got the members section here. There's a 300 question quiz as well. There's a tutorial. As you can see, the tutorial part 1, 2, 3, 4, 5. Warm-up quizzes as well, moving from low intensity to high intensity. So this is really helpful to cover the basics, but most important, do not forget to practice with real papers. After all, what they're testing is your real life skills to appraise the paper. So I hope you've enjoyed this session. I'm going to be doing more of this in the future, doing other studies, and I hope you join me for the next session as well. Good luck.